Our largest competition by far comes from overseas. We go anywhere in the US from 2 to 3 days FedEx ground. That's still gonna really beat anybody waiting 6-8 weeks for something coming from overseas. Our employees pay them very well. They are very specialized in their skills that we teach them here. Like many other filament manufacturers, we send all of our filaments through dual axis laser micrometers. But then when we move into our winding facility, we have our people there as quality control more than anything.
Plastic filament for 3D printing is often made overseas. It's cheaper that way, but it can take a long time to be delivered. 6 to 8 weeks is fine, maybe, if you are a hobbyist using 3D printing. It is not all right if you are in an industrial facility relying on 3D printing for production through additive manufacturing. So what does it take for a small US company making 3D printer filament to compete, particularly for industrial users? Not lower wages, not cutting corners, instead, fast lead times, tight quality control, and a supply chain that can be seen and trusted. This episode is about how one American company making something that might seem like a commodity product, 3D printer filament, is succeeding against international imports. That's coming up on the Z-Axis. The Z-Axis is brought to you by Workforce Factor, your onboarding engine for industrial employees. Stick around to the end of the episode to learn more. Welcome to the Z-Axis, the podcast about new directions in manufacturing. Most 3D printer filament is made overseas. It's cheaper that way. It's easy to order on Amazon, for example. And if the quality is unknown or inconsistent, it's still generally good enough, say for hobby use. But for industrial use, for say factories using 3D printing to make jigs, fixtures, tooling, even end-use products, good enough isn't necessarily good enough. Some level of knowability about quality and consistency of the input material is necessary, important. We visited Push Plastic, a domestic supplier of plastic 3D printer filament. They're not necessarily winning on price, but they're winning on quality, speed, trust, transparency. This is a story about manufacturing a price-driven product in the United States and what it looks like to stay in as a domestic source for that product. Tell me your name, your title, and who you work for.
My name is Seth Hollingsworth. I'm the president of global sales here at Push Plastic.
So for those who are completely unfamiliar with the company, tell me about Push Plastic.
Push Plastic is a extruder of 3D printer filament. We are located in Springdale, Arkansas. We have 12 employees currently and slowly growing. Our target market is anyone who is in the 3D printing space, specifically FDM.
FDM is fused deposition modeling. When most people think of 3D printing, it's what they think of. Plastic is squeezed through a nozzle that builds the part that's being made through 3D printing. The filament for fused deposition modeling is a long continuous strand of plastic, like a long plastic spaghetti noodle. Push Plastic sells this filament in 2 different diameters, 1.75 millimeter and 2.85 millimeter, and it is delivered in spools that range in size from a ½ kilogram all the way up to 25 kilogram. And what are kind of your core bread and butter materials?
Yeah, our core bread and butter would be our PLA, PETG. We've got our own formulation of PC, PBT, but we run the gamut from everything from ABS, nylons, carbon-filled materials, of PC, PBT, nylon, PETG, and ABS.
You have done experimental formulations that you've run, sometimes for research institutions. Can you talk a little bit about that aspect?
Yeah, we've worked with Department of Energy on a few ideas that they had and materials that they had concocted. We've private labeled for several companies at this point. We're still a small company, so I feel like that gives us the advantage to be able to take on, the strange, odd jobs here and there that some of the larger manufacturers just won't touch.
Small, 12 employees, 11 extrusion lines. That small size makes Push Plastic nimble when it comes to answering needs for specialty material when a need like that arises. Talk me through the filament making process.
We bring the resin in 1,650 pound, 750 kilo Gaylord boxes. It all comes in small nurdles, kind of like BB size. We then vacuum that material into a desiccated dryer, which is already step one of setting us apart from everybody else.
Drying matters. Moisture in the material creates bubbles, weak layers, failed prints. So, Push Plastic dries first, then extrudes.
We then, through a system of venturis and vacuums, send that into the extruders. It gets mixed with our colors. All those filaments get produced on anywhere from 50 to 70 kilo reels. Then we have a second check in the next room with our winders that will then take those large reels and portion them down to whatever reel size we have orders for.
Stop here, because this is where Push Plastic made a choice that might seem wasteful. Instead of producing the material so that it spools directly onto the reels that go to the end user, Push Plastic produces onto big reels first, and then in a separate room, spools down from those reels onto the reels that go to the end user. Why do that split? Well, the answer is because that separates production in one place from inspection in another part of the facility. What is unique about your approach?
We send all of our filaments through dual axis laser micrometers, but then when we move into our winding facility, we have our people there as quality control. A lot of people will extrude straight onto a 1 kilo reel, so you don't get that second check or second chance to get human eyes on the material and make sure it's good and ready to go. And
what are the kinds of things you do detect in your quality process that stop you from sending material that's not good to a customer?
Dye buildup, small neck downs in the material, bumps, blips, dye drool, could be a color anomaly that didn't quite get caught in the extruder room. Those guys we lean on a lot.
This is labor intensive, but it's core to Push Plastic's strategy. They decided to keep a human eye in the loop as part of their process, investing in skilled labor for the sake of reliability. Where in your operation is the most labor involved?
The most labor involved is in the winding room.
This choice serves Push Plastic's key customers. FDM, fused deposition modeling, is used in lots of different applications. Here are some of Push Plastic's key customers. 1, engineers, product designers who can't afford a failed print. They need spools of high quality material. 2, R&D engineers who need consistency, repeatability of input material to validate what they're exploring and developing. 3, industrial users making jigs, fixtures, other tooling, even end-use components. For them, the ruggedness of a reliable material is worth the price. Where are your competitors located, and how does geography affect competition?
So we're pretty fortunate to be in Northwest Arkansas and be in a fairly centralized location in the US. Our largest competition by far comes from overseas. We go anywhere in the US from 2 to 3 days FedEx ground. Our orders that are larger, the pallet size orders, the stuff that we have to build for customers, can take anywhere from a week to 2 weeks to get put together, but that's still gonna really beat anybody waiting 6-8 weeks for something coming from overseas.
Speed is Push Plastic's first advantage. 2 days for a small order, 2 weeks for a large one, beats 2 months. For engineers using 3D printing to prototype and iterate new product designs, that speed of material delivery can determine how quickly a new product gets to market. You account for your advantage in terms of time, but clearly the advantage of that competitor is in cost.
Yes.
And so talk about that a little bit. What accounts for the cost premium, say, of a domestically made product versus your overseas competition?
Yeah, so our employees, I like to think that we pay them a living wage, but we pay them very well. They are very specialized in their skills that we teach them here.
Push Plastic is not reducing wages or inspection steps. They've doubled down on a people-first, inspection-heavy model. and you rely on domestic sources of supply. Why is that important?
Well, our main material that we use every day is PLA. All of our PLA comes from NatureWorks. It's sourced right up the road in Omaha. It is very unadulterated. It's not chock full of fillers and weird chemicals. It's fairly well regulated in that sense, and we can assure the customer that what they're getting is what we say it is.
This is another intentional choice. Push Plastic doesn't chase lower resin cost and vary its resin supplier on that basis. Having a known, consistent supplier of the resin establishes visibility into the process. For companies in medical, aerospace, other regulated industries, this matters. Push Plastic can give those customers confidence. Because so much 3D printer filament is imported, and it's the kind of product you could buy it easily off of Amazon, you often encounter the assumption that Push Plastic filament must be made overseas as well, that you're just an importer and reseller.
Exactly. It causes some frustration. Once somebody realizes that, oh yeah, this material is made in the US, it comes along with a little bit more trust. They can pick up the phone and call us, and we're in their time zone.
They're also open. Push Plastic shows buyers their process, their extrusion lines. The material isn't just stocked, it's made right there at their headquarters. How do you define your product? I mean, 3D printer filament, it feels like a commodity. You've described some ways it really isn't, but play that out a little bit.
Yeah, you know, the plastics themselves are thought of as a commodity, but as a manufacturer of 3D printer filament, we really lean in on our precision, accuracy, and quality more so than anything.
The plastic material is a commodity in a sense. The filament made from it is something different. What do you know or suspect about how much of your business comes from commercial versus hobbyist or home users?
Probably 50-50 consumer versus, manufacturing or end-use customers. It's really tough to figure that one out. The engineers in corporate America that buy the material for their organizations, it could be very small quantities and then turn into very large quantities. They could be buying it from home and using it in their home printers before they convert their business into using it. So it's hard to figure that one out.
Desktop 3D printers can make industrial quality parts, so that blurs the line. A Push Plastic spool of material might be used in a garage today, a factory tomorrow.
Molds that used to be made out of metal or aluminum, for instance, could be replaced with a PCPBT mold for small run parts. And if it wears out, they could print a new one. Jigs and fixtures used to be made out of metal. It's a lot easier for an engineer to draw something up in CAD and print that out and have it 2 days later.
So what is next for Push Plastic?
Our next step that we're really ready for, we've been working on it for a while now, is ISO 9001. As we grow, I feel like US manufacturers are gonna start to take back what was previously bought from overseas. As much as we like to think of the other US manufacturers as being competition, I really see it as us leaning on the other ones and seeing what the other ones do and somewhat working together to get to that point where we take a larger market share than the foreign market does.
Push Plastic isn't trying to beat overseas filament on price. Instead, they're aiming to win on speed, consistency, transparency, trust. They offer a picture of what it looks like to manufacture what's seemingly a commodity product, but actually anything but. Thank you, Push Plastic, for hosting us. We have another episode in development about how Push Plastic staffs their facility. Watch for that episode coming soon. I'm Peter Zelinski. You can get more of my stuff at ZelinskiReport.com. This show, The Z-Axis, is a product of Edge Factor, and if you like this show, please subscribe. It really helps us. Tell a friend about it. Tell others who are interested in the advance of American manufacturing. Until next time, hold your tolerances tight, your faith and family tighter, and hold lightly to everything else. Workforce Factor is the new, customizable onboarding and upskilling engine for industrial employers. Where should training begin? How can skills development continue as employees grow? Workforce Factor is your company's tailor-made platform for addressing this challenge. Possibilities include technical courses, introductions to machining, welding, additive manufacturing, and more. Personal skill courses, introductions to time management, workplace ethics, financial literacy, and more. We are working with companies ready to systemize the approach to developing promising employees into skilled professionals. Contact Workforce Factor today.